energy profile diagram. Simply put, it is a diagram to represent enthalpy change of a reaction. However, it is slightly less straightforward than we think. We need to first know about activation energy before we can actually draw up an energy profile diagram. So, activation energy. Even though some reaction may appear overall either release or absorb energy, all reactions need to initially absorb some energy to get started. That is because old bonds, the bonds of the reactants, must always be broken first for new products to form. And of course, when you form new bonds, energy will always be released. But we always need amount of energy that to kickstart a reaction, and that is called the activation energy. And the enthalpy change, or whether a reaction is exo or endothermic, depends on the net amount of energy that it will be released or that will be consumed. So, since both exothermic or endothermic reactions need a kickstart to begin, our energy profile diagram will look somewhat like this for exothermic reaction. Reactants will first absorb some energy, and then energy will be released to form products. And this will be exothermic reaction. So you can see the energy that was absorbed to kickstart will be less than the energy that was released, and therefore it's exothermic. On the other hand, if it's an endothermic reaction, you can expect that more energy is absorbed to kickstart the reaction for energy to be released then to form new bonds. Okay? So activation energy is measured as the gap between the energy of the reactants and the peak energy of this reaction. It's always this gap that's the activation energy. Yeah? And the substance at this peak, at this energy peak, is called an activated complex. Okay. So for an exothermic reaction, as we've seen before, we should start with reactants, goes all the way to the top, and that part is our activation energy, and then energy will then be released to become products. The reason that it is a curve rather than a perpendicular line is because the x-axis is the reaction progress. So as the reaction goes forward, it's going up. And for endothermic reaction, you can expect a shape that's like this. Yeah? The reactants absorbs a lot more energy than when energy is released to form products. And from products to reactants, this vertical gap is your delta H. Now, let's try a question. What is the enthalpy change for the forward reaction given this energy profile diagram? Well, if you use the energy of the product, the enthalpy of the product, to take away the enthalpy of the reactants, then you will get a negative 80. So remember, the enthalpy change always comes with either a negative or a positive sign. You can try this question by yourself.